as well as
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
We were fortunate to witness the monumental launch of SpaceX's Starship on its 6th test flight, marking another significant milestone in space exploration. At T45 minutes, the countdown clock started, and final checks on the vehicle's systems were underway at Starbase, Texas. The team confirmed the fueling of both stages with liquid methane and liquid oxygen. The weather was assessed as favorable, with only light wind conditions at the launch site, setting the stage for a smooth liftoff. At T-10 minutes, the launch director gave the final go for launch. The automated sequence took over, ensuring all 33 Raptor engines on the Super Heavy booster were primed and ready. At T-1 minute, the ground cameras captured a dramatic venting of vapor as the pressurization of the tanks reached its peak. The countdown approached 0, and the Starship stood tall, gleaming under the afternoon sun. At T+0 seconds, the ignition sequence began, and all 33 Raptor engines roared to life. The launch tower arms released the vehicle, and Starship Flight 6 lifted off from the pad in a spectacular display of power and light. The vehicle climbed steadily, leaving behind a thick plume of exhaust visible for miles. The engines performed nominally, delivering maximum thrust to the vehicle. Telemetry data showed a rapid rise in altitude and velocity. At T+2 minutes, the main engine cutoff mecho occurred as planned. The Super Heavy booster completed its burn and separated from the upper stage. The separation was smooth, with no signs of anomalies. The booster began its descent back toward Earth, flipping its orientation to prepare for re-entry. Meanwhile, Ship 31 ignited its vacuum-optimized Raptors, propelling itself toward the edge of space. At T+3 minutes, the Super Heavy booster executed its first controlled burn to slow its descent. The grid fins deployed to stabilize and guide the booster back toward the Gulf of Mexico. SpaceX was attempting a soft splashdown rather than a pad landing, aiming to gather critical data on the booster's descent dynamics. At T+5 minutes, Ship 31 reached its apogee, marking the edge of space. The vehicle's onboard cameras provided stunning views of Earth below. For the first time in a test flight, one of Ship 31's Raptor engines was reignited in space to simulate orbital maneuvers. The test was a success, demonstrating the engine's capability to perform in the vacuum of space. At T+6 minutes, the Super Heavy booster began its final descent toward the ocean. It executed a second controlled burn to reduce velocity further, aligning itself for a soft landing in the water. Observers noted the booster's impressive stability during descent, with the grid fins making continuous adjustments to maintain trajectory. At T+8 minutes, Ship 31 initiated its re-entry sequence. The vehicle's thermal protection system, composed of heat-resistant tiles, endured extreme temperatures as it descended through the atmosphere. The aerodynamic flaps on the vehicle adjusted dynamically, maintaining control as the ship reoriented itself for landing. At T+9 minutes, the Super Heavy booster splashed down gently in the Gulf of Mexico, completing its mission. While SpaceX did not recover the booster, the soft splashdown provided valuable data on descent and splashdown dynamics, paving the way for future reusable launches. At T+10 minutes, Ship 31 performed its final landing maneuver. Using its aerodynamic control surfaces, the vehicle reduced its velocity further before executing a controlled splashdown in the Indian Ocean. The landing was precise, with the ship touching down exactly as planned, demonstrating SpaceX's ability to accurately target landing zones. SpaceX kept the world updated throughout Starship's 6th test flight, with key tweets that highlighted milestone moments. The first significant update came with a tweet announcing that Starship had successfully ignited one of its Raptor engines while in space for the first time. Reigniting an engine in the vacuum of space is no small feat. It validates the upper stage's ability to perform necessary maneuvers, such as orbital adjustments, lunar landings, or even a return to Earth. Shortly after, another tweet followed. detailing that the Super Heavy booster had initiated its landing burn and performed a soft splashdown in the Gulf of Mexico. While the booster didn't return to a launch pad or get caught by the Mechazilla tower, the splashdown allowed engineers to test controlled descent and precision targeting. As Ship 31 prepared for re-entry, it faced a unique challenge. Certain sections of its heat shield were intentionally left uncovered. This design choice was made to test the vehicle's thermal protection system and to gather data for future missions where the Starship might be caught by the launch tower's arms, known as Mechazilla. During re-entry, the vehicle's thermal protection system, composed of heat-resistant tiles, endured extreme temperatures as it descended through the atmosphere. The aerodynamic flaps on the vehicle adjusted dynamically, maintaining control as the ship reoriented itself for landing. Despite the missing heat shield tiles, Ship 31 executed a controlled splashdown in the Indian Ocean, concluding the test flight. This successful re-entry and landing provided valuable data on the vehicle's thermal protection capabilities and will inform future design improvements. Many of you might be wondering why SpaceX didn't attempt to catch the booster with the Mechazilla arms during Flight 6, especially after the success in Flight 5. Observations during the liftoff provide a likely explanation. The Lightning or communications tower on top of the integration tower appeared to sustain damage during the launch. The sheer force and heat from the 33 Raptor engines at full thrust likely affected the structure, making it unreliable for a precise booster catch. Given the potential damage to the tower, SpaceX likely opted for a controlled splashdown as a precaution. The catching process relies on accurate feedback from the tower systems, and any issues with stability or communications could risk damaging both the booster and the catching arms. This mission may also have been an opportunity to test alternative recovery scenarios. By splashing the booster down in the Gulf of Mexico, SpaceX could gather important data on how it performs in controlled descents without relying on the tower. Given the success of Flight 5, many of us were expecting something extraordinary from Flight 6. Flight 5 shocked everyone when SpaceX achieved the remarkable feat of catching the booster mid-air with the Mechazilla arms, a move that demonstrated unprecedented precision and engineering. Naturally, this set the bar incredibly high for Flight 6, with expectations that SpaceX might push the boundaries even further. Some enthusiasts and analysts even speculated that SpaceX could attempt to catch the upper stage mid-air, a feat that would redefine rocket recovery entirely. However, Flight 6 didn't quite live up to those lofty expectations. Not only did SpaceX decide not to attempt catching the upper stage, a move that, to be fair, was likely never on the cards at this stage of development, but they also opted not to repeat the dramatic booster catch from Flight 5. Instead, the booster performed a soft splashdown in the Gulf of Mexico, which, while still a significant technical achievement, felt like a step back for many observers who were hoping for another jaw-dropping display. Additionally, Flight 6 seemed to focus more on testing alternative recovery scenarios and gathering data for future refinements, which meant some of the visual spectacle and groundbreaking achievements of Flight 5 were absent this time around. Thanks for watching, and don't forget to subscribe to our channel for more updates and exciting news about Starship and SpaceX's incredible journey.